Welcome. Great to see so many of you showing up on a Friday afternoon. My name is Vidar Eidissen, realizing that we are here in Latvia. It's, of course, Vidar Eidissen. I have a very strong feeling for the... yeah, thank you. I have a very strong relation to this city because like 14 years ago, I went on a work project here with a colleague of mine, which turned out to be my future wife. So we are actually, our three boys are actually the most concrete example of our then company's expansion to or going abroad. So that's the success story about that one. Okay, a little bit more about me. I work as a consultant, developer, kind of a DBA stuff. I don't do patching, backups, installing stuff. I basically run the RN that, or the software that I'm delivered, try to do it as fast as I can. I've been working with database since 1998. We installed the two first rack installations in Norway, like number 17 in the world on 9i. That's, yeah, there were bugs, 9i on Windows. Really cool. Spent 23 years building a company for medical records in Norway, building pretty large databases after a while. That was a client-server application with like 8,000 concurrent connections, quite a few terabytes in documents and stuff. A few years ago, I decided to go into consulting, do something else. I've done a lot of ETL, former performance support or development. I like to put stuff into the database because it runs faster. I like speed. Yeah, I have a few certifications. Looks good on your resume. And I also have a DBA certification on 8i, which is from 2001, I think. Never renewed that one. I live up here, Norway, which is basically on the same parallel as around Point Hope in Alaska. But of course, you're a European, so you understand the concept of the Gulf current with the warm waters and stuff. Town has about 50,000 people. Looks like this. If you know any history, this was the airbase in the middle of this town here where Francis Garrett Powers was heading for when he was shot down in his U-2 in his 60s over the Soviet Union. I work for a small company. We're just 4 people. We spend a lot of time doing conferences because we think it's fun. We learn stuff. We like to share stuff. We are getting old, as you see, so we need to bring the knowledge on to other people. So that's why we do this. So we actually encourage our small team to go out on conferences. And it's fun. It's kind of daring, but it's fun. This presentation is actually a horror story, but spoiler, it goes well in the end. It's about, we're going to talk briefly about the project that I worked on, about the code base that we discovered, the challenges we had, solutions we found, and some other stuff we learned on the way. The task was that we had a customer with a CRM application that needed a GDPR-compliance review. So we had to go in and check code that other people had written, and we had to create the get my data routines and all of that stuff. It was developed internally by this company for more than 10 years, using quite a lot of consultants on shorter or longer terms with different styles, different ways of doing stuff, and different knowledges, and I might add abilities. So the code base was not homogeneous. It was very different and quite unorganized. The team we had was externally sourced, only externally sourced. 7 people initially, 1 project manager. He was the only one who actually had any knowledge about the product, about the software. We had a couple of GUI guys, 4 database developers, 1 more of a DBA kind of guy. We were reduced to 5. 1 of the GUI guys left, and 1 of the database developers went on to another application inside the same organization. Yeah, about experience. So we were basically running blind here, with a little help. The architecture it's what you would call a hard shell PL SQL application, so that all the business logic was inside a database, in stored procedures. So there was very little going on the outside. You would have different clients running against this code base. All the interactions through PL SQL, just a few exceptions, very controllable. Yeah, I said all this already. It looked something like this. Let me just change this one. Wrong. Yeah. So you would have different kind of clients. Customer support, you would have like the customer self-service pages, and you would have like mobile apps running through web servers, executing packages, and then accessing tables. And that was very good because I always used functions or procedures doing all this stuff. But that concept kind of stopped inside the procedures, so that every time you open a procedure, you wouldn't see many calls to any other source, really. You would just do everything in that procedure and return out again. So some of them were really, really long. And they were accessing tables all over the system. That we found out after a while. The code base, I took a look in the dictionary to just try to orientate myself, and I found like more than 2,500 tables, more than 450 packages. Types were in for a while. They stopped using most of those, but we didn't know what was in use or not. Triggers, more than 400 of those, mostly handwritten. More than 600 views of different kinds, 150 standalone procedures, functions, 300, primary key constraints, 301. Okay, so there's something between that number and that number. So I was hoping for, how about unique keys? No. Okay. Is there a data model? No, well, there were a few spreadsheets trying to organize some of the code, but mostly not. So, okay, I can use this SQL modeler and reverse engineer the ER diagram, only not. So documentation, I mentioned that, not so much. We had access to the developers, so we could interview them, and we had some educational rounds on this. But we were basically, looking at this, I was like, where's the fire escape? I need to get off this project. I have no idea how I'm going to deliver here. I will not be able to deliver. Went into all source, found more than 1 million lines of code outside of the syschemas, 90% of that in packages. Could do, the web shop guy said we do the stuff on ourselves. We have control over this stuff. So okay, so we're down to 500,000 lines of code. I tried searching through the code base, found the keyword select 20,000 times, more than that. 6,000 insert statements, 6,000 updates, 2,000 deletes. So there's at least like 500 tables which are never being deleted data from. So we need to do some stuff here. We started, well, just starting somewhere. I convinced the team that we should install Apex and build an Apex application, so that we went through all the tables and started classifying them, getting help, questioning about do they have any sensitive data, should we keep them, drop them, should we anonymize some of this stuff, or do we have to code retention? Should we delete some of the old data from them? So we went through that, and we had like this, I should have taken a screenshot of that. We had nice gauges of, oh, we're up to 700 tables gone through now. So we could follow the process there, writing down remarks and stuff. So we quickly discovered that we have some data that we don't want, like social security numbers. We could not store those. We need those for a short period of time because we needed to identify the customers, but we were not allowed to keep those. So we need to get rid of those, clear them out of the system, and replace with something else, and find all the places where we had to go into. So deleting is not enough. Where does it come from? So if we delete it, if it's re-entering the system from somewhere, we need to find out where that is. where it's been manipulated, like updates, inserts, deletes, and where is it being used? There's like 20,000 selects. So staring at this, again, 20,000 select statements. We're like, so how do you do quality assurance on 20,000 select statements on a system that you don't know? So we didn't know, so we didn't, basically. Easy way out. I said we thought that if we can control what's coming in to the system, it might not matter where it's being selected. If you select a blank column, it doesn't matter. So that's an easy way of doing that. So finding and controlling these entry points for data became very, very important. That's and we wrote our own. We were thinking about we write our own low-level APIs where we redirect statements to use these APIs instead, because we need to have control over the life cycle over the customer identification data. We need to have validation so that we check if anything is changed, like a name or whatever. We do a check against official registers, and by that increasing the quality of data coming in, as well as increasing the quality of the data that's already in the database. Running queries on all source. You probably know this view. You have a view where you have available all the source in the packages unless they're wrapped. Doing regular expression of those were not giving us anything. As I said, we had references all around the system. So if any of you have, by the way, how many of you are PL SQL developers? Hand in the air. Oh, that's good. Any of you doing like Java.NET using Hibernate or in Hibernate? Yeah, you guys should pay attention to this. Because if we think, I'm an old guy. I started out in 1993 in a regular job. So I've seen systems over time, and everybody's always working on the last application ever built against these data, right? It's not ever going to be any new stuff, is it? But I worked on an application that had version 1, the old classic version, client server. Then we started the web services stuff, version 1 of that, and then went over to the new version of the web services because this one wasn't good enough, so they started a new version. Then you had 3 code bases here. And every SQL statement is a hard coupling. It's a hard binding into your tables. So what basically happened was that changing the data structures down here became virtually impossible. So even though, yeah, I can map this out, up in a file or whatever, we have control over that. No, you don't. You only have control over your own little domain. You have no control what these guys are doing. These guys are actually using an old deprecated version which nobody's going to touch. So they will not upgrade at the same time as you do. Okay? Really, really important to think lifespan about this. It might be boring to write stored procedure, but it's going to keep your database more agile. Stuff works, trust me. Where was I? Yeah, we had references all around. So one table could be mentioned a lot of places. So I said, I would check out PL Scope. I went to a presentation about that with Bryn Llewellyn once and Sabine Heimsat. And I actually came home to my office and I ran those utilities on the code base that we had, and realized I was the only guy writing structured PL SQL code. Everybody else was not doing what I asked them to. The rest was just small helper function being called from SQL statements and stuff that you really don't want. So I gave it 2-3 months and then I quit. PL Scope is a metadata collection tool that's inside the database. It came out with version 11, and it got improved with version 12 because it collects statements out of your PL SQL code. Only works for PL SQL code. It doesn't work for any statement or anything coming from the outside in being run and being put out again. Okay? So it's a pre-compiler for PL SQL that does this work. Collects it, putting stuff into some repositories, which you can query. And what's an identifier? An identifier is like a table, a column of a table, a variable, a constant, a procedure name, package, basically any small object you can think about in a database. There's no extra license. It's off by default. I noticed it was on in our cloud-based server, but I don't know if my colleague switched it on or whatever. So I'm not showing you how to set it up. It's basically just setting some attributes and recompiling your code. That's it. There's basically no performance overhead either. So what did we do? We were running 11G at that customer, so we got our development environment upgraded to 12.2, tested out this stuff. We also needed some of the new JSON stuff to generate the customer data, tested it, and put pressure on upgrading the production database as well. Because we were lagging behind the production database because the developers didn't always have time to develop stuff in test. Ever noticed that? They just put it straight into production, so this was a really gung-ho environment. So we needed to close the gap. We had like a few months of development before we realized, oh, so we are struggling here. Did a test. We had to find inserts into central table, so I queried the source doing regular expressions or something like that. Find 950 matches for a table. That's way too far to do anything with that. We cannot do that with 2,500 tables. Searched all statements, which is one of the use in PL scope. I'll show that one later on. Ended up with about 50 or 60 statements because you can select if you are looking for a select statement or an insert statement or a delete statement. So you can actually quickly filter down, and having like 50, 60 insert statements or update statements involving the same table seems a lot as well. And yes, there were duplicated code and old code. Anyway, we exported that to a spreadsheet. We did that quite a few times, doing these quick results and getting them out to a spreadsheet, putting it in Confluence, and started working on ticking off which one we were working on. So looking at the statements in a spreadsheet, we quickly came down to about 15. You could just tag, oh, we need to look at this one, not that one, that one. Okay, good. So a couple of minutes, few minutes, from 950 down to 15. Excellent proof of concept for us. Makes it manageable. Now, not many graphical tools around this. Philip Salvesberg has created some PL scope utils which you can import into SQL Developer, but they didn't work for our case. But you can check it out as well. Oh, by the way, slides will be available later on. There are some links here and there and at the end, so you can find some of this stuff. And the scripts I'm going to show you later on, they're all accessible on GitHub, so you can download them and try it out yourself. So we started writing our own queries, checking out the blogs from like Stephen Feuerstein. And we initially tried doing the correct stuff or doing recursive queries and stuff. Realized this is complex to get them right, to understand what you're looking for. And also with a code base of 1 million lines of code, that metadata becomes a little bit huge, and the queries ran slow, several minutes maybe. So we realized that we can actually simplify a lot of this, getting a few false positives and spending less time sifting through those false positives and writing the correct query. Yeah, the queries ran faster. PL scope utils, you can install it and it shows up in the graph, and you can get links like this because I won't say anything about that. Use cases. We could actually find out stuff like where is this table being manipulated, like inserts, from where is this procedure called. You have some dependency views in the database that says that this object is being referenced by somewhere in here in this object, right? You can see that a package references a table, I think, or a package referencing another package. But that's quite rudimentary. Where is that in a stack of 450 procedures? I know the name of the method, but I cannot remember the name of the package. So you can, okay, we can find that one. We get a question from the ETL guys. They said, well, you noticed you added some columns. Do you have a documentation of that? No, we documented as much as you guys, which is nothing. We can find it out for you. What are your packages called, and what tables are we talking about? We also had queries from StatPack, AWR reports. I do a bit of tuning. I think that's really fun, being a superhero in like no time. So we could pick out queries from there using the SQL ID, finding the source of that code, and maybe rewrite that code or change the query if we needed that. Finding duplicate statements, quite a few of those. There were some packages with a ridiculous amount of constants, so we started removing some of those. Fixing response errors like HTTP responses that were defined as varchar2 instead of clob. Where is this being referenced? It's the same as the other one, by the way. Yeah, more performance analysis. Is this function suitable for result cache, or can we add? We need to add an index. Can it be unique? So easily finding the manipulation, so we know that, okay, so this is actually being inserted from a sequence and it's never updated. Okay, it can be a unique index. Okay, short about enabling PL scope. It's, as I said, you might either compile separate objects, but to get full effect of it, you should compile all of your objects, because the object you're compiling and its references to other objects is what being tracked and generates IDs into the system. So you can turn it on the session or system level. We started up on the session level, and then we just put it on the whole test system. And after a while, we just enable it on the production system as well. No problems whatsoever. You can also enable it in SQL Developer. You have this PL scope identifiers, set it to all. Just turn it on database level. Okay, some demo time. See if it works. Can you read this? Okay, in the back as well? Should I make it bigger? Is it easier? Okay, good. Okay, so what I've done here is that you have the sample HR schema in the database, and I've added 2 more tables just to show you some of the ins and outs of this. We have employees, and I've added employees history with an underscore and with the whole name, and I've created a view as well. So I have these tables: job history, employees, regions, and stuff. So first of all, we can start looking at the code base. How many objects do we have in the database? This is what I did at first at the customer site, just to find out something about it. So, and finding out how many lines of code is there in the system. If we just count from user source, I get 306. If I select from the user source, we can see that, okay, I scroll to the bottom, we have 306 lines. However, there are blank lines here. Might not want to count those. The funny thing is that those lines are not null actually. There's something in them. We cannot trim it, but we can do a regular expression on that, and then we get 246 lines of code. If we look for the keyword select, doing a standard string search, so we see that we have the select keyword 12 times. That's what I did at the customer site and got that answer 20-something thousand. But if I look at the text here, is that I have a few notes is that this one is actually commented out. If we go to line 95 in the employee's body here, let's look at this. 95, you can see it's commented out. So it's a false positive. And we had a huge amount of those, obviously. Because, there were no version control system. You just change code and put it into production. So doing regular or basing your strategy of changing stuff on doing regular expressions on source files is not going to work in any decent size system. It works for a tiny module, but after that it just gets out of hand. So that's why you shouldn't put SQL statements in resource files concatenated in code in .NET or Java or whatever. Put the statements into the database, you're going to be much better off. It seems silly, but it's actually better. I will show you a few other things later on. Okay, well, you can also select from user procedures. I don't know if you know this, guys. We can find procedures, packages, triggers, and we can pick up the name of those. These are some of the standard views. This does not belong to PL scope, but I'm just showing that this exists. You also have the user arguments table, or all arguments, where you have an object name like and a package name, like the package employees with the procedure add employee, and you have all the parameters to that procedure. This is nice because anybody here using Logger, the Logger framework? Oh, good, you're going to learn something because I have that in the end. Maybe I can come back next year and talk about Logger. Because we can easily, from that we can easily generate the code to collect the parameters from your procedure. Because if when I log when a procedure fails, I tend to log the parameters for that procedure, so I know with what input values did this crash. So instead of typing that, I just generate it. Especially when I re-instrument old code, I do it like this, and I have snippets to do all of this stuff. Okay, so the PL scope structures, there are basically two tables. It's identifiers and statements. It's very easy initially. So what do we have here? We have departments, which is a type table. It has a signature. This signature is unique. It's just a GUID, and it's unique, and all references to this table uses this GUID in this set of metadata. We can also say that we have department ID, which is a column, and it belongs to the object departments, which is our type table. And if we look over here at the usage ID, they are incrementally numbered, but this one has a context of that table. Okay, so this concept is kind of important to get a grasp on, and on this you can write hierarchical queries, kind of redesigning or retyping your code if you want to. That might help you to understand the structure of it. But the point is that this one exists in the context of the departments table. Same thing if we go down to a view here, we have columns of that view belong to the context of that view. Same thing with procedures, and like this procedure here, assign an employee to job. It's a procedure, and it has a formal in parameter, and so on. So that linkage might be very important to you, and understanding this point of with the signatures. So finding the correct signature to determine what you're looking for is the key thing in the methods that we did. Same thing with user statements. They have some of the same columns, but this one collects all the SQL statements in the system. So we have a signature for that statement, which is the same thing. We have a type. If it's a select update, we also see that we have commits and stuff. Where it's located, it's a package in a package body on the line number, and we have a SQL ID. I'll talk more about that later on. And we have the text of the statement here. Notice that all these statements are uppercased, because when the PL SQL precompiler goes through the statements, it uppercases all the keywords and removes any extra white space, removes remarks except hints, so that if you have two actually equal statements, they will show up as the same statement. So it kind of saves cache there. That does not happen if you send statements from the client and inside to the database. They will come just as you wrote them. So getting the complete picture means doing a union all on this one. So we can see that we have we have tables, we have views, we have packages and stuff in here. For you now it's just a bunch of data. So as I said, all the scripts are out there. I'm just showing you the concepts now. So again, how many lines of code do we have? If we count we can see that every line could be referenced several times, and only those lines with code. So that if you have several identifiers on the same line of code, they will be repeated here. So basically you can just do a count on that, And we're now down to 253 lines of code instead of the 240 something. On the system I was on, we came down to 240,000 lines of code. And this is kind of playing a mind game on yourself, because 240,000 is a way lot less than 1 million. So, okay, we can do this. Come from several schemas, we don't go into that. So if we re-explore all the statements now, we can see what types we have. We have commits are registered, execute immediates, inserts, open, select, updates. And on the system I was on, we had like 2,790 commits. Compare that to inserts and deletes and updates. So committing is frequently was a habit in the system. You typically say insert, commit in the same procedure, because they had bad code, so they saved whatever they could save at any time. We can also look at the identifiers. What kind of types do we have there? Or usages. We have assignments. That's when a variable gets a value. You have calls. That's when you call something, a procedure or a function. You have declarations. When you declare a constant or a procedure, that's a declaration. If it's declared in the body, that's an internal one. And the definition of it is the actual implementation of that. So that if you have a public function, it would have its declaration in the header and the definition in the body. And also references, which would be tables. If you're looking for references to a table, you would search for reference to this ID. We'll get into that. So we had like 372,000 references. Okay, let's look for a table then in user statements. So we could go for the ID of a certain table and see where it's being used, and do that context search stuff with the hierarchical query. But we found out that doing a search like this is much quicker just doing a string search. But you see that if I'm searching for the employees table here, I have a few false positives. Where are they? Like employees history, employees underscore history. So by using regular expressions and knowing that, okay, if it's a table name, it has to be a non-word character on each side of it. So doing that, we suddenly have the 10 statements involving that table. It could be a select into another, insert is select into another table, but you can quickly find those and rule them out. You can also see here that hints are being traced like this. They are left in, but remarks are being removed. From where is this procedure called? Okay, so we are looking for the declaration of a procedure manager for department. Finding the declaration for that shows us the signature, and we can use that as a subquery factoring. Or what's this? There's a new term for this. Common table expression. Yeah. So we use that as my signature, and we can do that as a join on the identifiers table, and immediately we have two places on line 9 in the payroll package. Let's see if that's correct. Line 9, manager for department, yes. And on line 55 in the employees package. Let's see now, 55, manager for department, yes. Easy? Really, really easy. I don't use SQL Developer as a development tool. I write my code in some other tool. I don't get the flow of SQL Developer, but I do like the reporting capabilities in it that the grid offers. Because if you add these special named columns like sdev link owner, link type, name, and line, they won't show up here. But what they do get you is that you can now right-click on this grid and you can go to the payroll package on line 9. How cool is that? Same thing here, go back, line 55 in the employees package, go to employees, kaboom, you're right there. So you can inspect the code. This is to me, this is a really powerful feature. And then I'm kind of a bit annoyed because I have to switch my other development tool to change the code. But it makes it so much easier. Finding where that procedure was, if we don't remember that manager for department was in a given package, we can find that name in the identifiers. You might have more positives here if you have a to-bool or whatever, a standard function. In several places you would find all of those. Maybe collect them. Finding dead code, this is cool. But when I delete code, I feel almost a little bit smarter. It means I found a better way of doing stuff. So if we look at the declarations of functions and packages, there's quite a few of those, right? So what can we delete here? Well, we have all the calls to functions and procedures are registered as usage call. So if we run that one, these are all the calls to functions and procedures. And using standard set-based stuff, we can actually just do that. Okay, select from all declarations. Right now we're looking for those that are declared inside a package body that doesn't have any calls from the outside or inside or wherever. So we do this, and we can see that the add to history, these are declared inside the package body. They have no calls to them, so these are actually safe to delete. That's nice. For externally declared procedures and functions, it's a bit of a different picture, because then you need to have a good schema of how you grant stuff. If your application logs onto the same schema and you can execute every procedure, you will have to search through the code on the client side to figure out what's being used or not. But you can produce a candidate list on the same way, because we have all the declarations here, and we can take away those who are actually being called from PL SQL code. So this is a candidate list for deletions. Well, these package body ones can be deleted, but those that are in the package are candidates. So you will have to search your other code for that. However, and that's why you should not putting SQL statements into your clients, because searching for this procedure name is a whole lot easier than doing regular expressions on SQL statements. Do you agree? Anybody not? Good. Yeah, listen up, guys. Yeah, the question about how we're on time. Oh, there. So oh shit. Okay, we can do. We're going to overrun a bit. About this ETL package, guys, that I talked about. Okay, we have a table. These are all the columns and identifiers, so we can see which ones are being referenced. We have all the references to tables. So we have from these are actually columns that are not referenced by any code. So when we knew the name of their ETL packages, we could go and inspect those packages. Which tables are you actually using? Okay, are any of the columns left out because you're not doing select star? You have named columns. However, this is not quite right though, because department name here is actually used in the employees departments package. Where is it? Employees departments. Line. Employees in departments. Yeah, well, the point is, if you have a row type, it doesn't record that you're using the column actually. You see, if you declare a variable based on a row type, that column is not explicitly tracked. So watch out for those. Pardon?
And execute immediate statements.
Yeah, dynamic code is like client-side code not getting tracked. So stay away from dynamic code as far as you can. And performance troubleshooting. Oh, this is the fun one. If you have seen AWR reports or anything like that, you have the SQL IDs. So if you look at all statements, the SQL ID here is the same one that you see in VDOL SQL views, in references all around. This is basically the hash of the SQL statement. So it's very, very easy to find out where this statement is coming from. if you're doing SQL from the client, you should be very, very thorough about tagging where the statement is coming from, like using a remark and saying it's in file so and so on or whatever. But this one does it automatically. Here we have duplicates. It's the same statement on different places. If we look at the where are we? Employees 114 and it's what did I say? 104. What did I say? No, it's line 68 and 88. Sorry. 68. Select star from employee from employees. Blah 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 blah. And we have the same statement here with a remark that's being removed. We have different casing. This one's uppercase, this one's lowercase, but the precompiler does all of this to it, so it looks the same. You can also list out the source code around those if you want to, so that you can easier inspect the code around without jumping in and out of packages. Finding duplicate statement is easy. Removing constants, I'll leave that for you. We need the rest of the time because I want to show you. I would like to show you. Where is it? Where is it? Where is it? What table we're referencing? Ah. Where did I put? Oh, here we are. I will just first flush my shared pool. Some of you might like this one because I'm going to run one heavy procedure which does a few select statements. And while that is running, I created a set of reports for not logger logs. No, I've done that as well. For top SQLs. So you can actually, I took the standard reports and I added links to the SQL developer or links to the PL scope stuff. So if I go on the top SQL by CPU, not on that database, I run it on the local one. I can list this out. I get the stuff from Visual SQL, executions, and I can jump. I can find these statements in the source if there are several statements, and I can jump into the code. I thought, where is being referenced? Hey, here we are. So using those standard reports with these additions, they're all on the GitHub as well. Finding the source for it, and now I can go and fix it. Easy, easy, easy. Okay, that's it for demo. Download the scripts. I have put comments in there so you understand what's going on. It should be easy to run it. Let's do more of this stuff. Yeah, views are not tracked, but if you have updatable views or instead of triggers, they are captured in the trigger code. Any dynamic reference, like execute immediates, avoid those. Open for with strings, avoid those. Developers job and scheduler also uses dynamic stuff, so you need to write some procedures so that you can check those for the function calls of yours. Please do not reference tables directly there, just call up procedure instead and do everything in the procedure. Row types, as I mentioned, synonyms. And Philip Salvesberg has done some stuff on this with views and things, but we didn't have to use this because as we knew our code base, we didn't have to go after all of this. Wrap packages doesn't work, of course. Code is unreadable. Success factors for us was that it was a hard shell PL SQL application. There were no statements outside, and we had, although we had several clients with different code bases, they would only call these procedures. And we could search for these specific function calls, and finding our way through the PHP code was same nightmare as well because we didn't know what was in use or not or out of use. So end result was that we actually have more control of who the customers are, because if you're going to deliver GDPR data to someone, you need to know who they are and thereby what their data are. So we actually laundered a lot of data. We implemented daily checks with PL Scope. So if someone adds a column or a new table, there's a nightly job running and checking, oh, there's a new column here actually, which is not being referenced by the retention packages. So someone has to tick off that it is okay or write code for it. So when we left, they had a dashboard where this shines up. Quick notes at the end. Logger, very good logging tool. We did some improvements on that. We changed code all around, so we had to exchange their rudimentary logging framework, which was they just basically wrote where they were, which was always very often wrong because procedures code were copied and the procedure names were not changed. So we do this all automatically now. We just started replacing statements, didn't ask for permission. I've created a set of reports. It's on GitHub. I do the same stuff there with a jumping into the code, so that if you have an error statement, you can jump right into the code. Easy. Just import it into a SQL developer. Shows graphs like this. This is some live data, I think. You have errors, infos, debugs, warnings. Some reports, most popular errors. And we could jump right into the package here, so that we saw that one was very popular, so we checked that one. Same thing, bad examples really. Lots of lists. Yeah, by using the timestamps we could find. We used something called scope. We implemented an automatic scope, so that whenever a call came in, we set that scope, and every log statement belonged to that scope got that business transaction got the same scope, so that we could drill down for this transaction, this order entry, and we'd get like 20 log statements belong to just that one, because when you have a huge pile of log statements like this and organized, which belongs to which session. So we use that. And thereby we could calculate time for the scope, find out big gaps. We have call stacks, error stacks. This is when we first put our huge batch of change packages into production. Those were basically not our errors. And over time we just started fixing errors. These are errors per day. We just fixed errors that weren't ours because it was so easy. Because we had Logger, we had the input values, and we could easily see what was going wrong. New large set of packages being instrumented, and mind you, this is a logarithmic scale. So we did pretty well. Good team. My Danish colleague he was amazing. I did the methods, he did the work. So very good team. Pragma deprecate, you can tell by a set of compiler warning that this code is no longer in use. Realize that the people using Toad, which I don't like either, did not have compiler warnings set on by default. So I was basically the only guy with compiler warnings on, and I get a rash when I see compiler warnings. I don't like them. It means that something's wrong. A good design. I'm actually now on a new project, a greenfield project, where we are doing something like this. We don't do the low-level APIs, but we have business logic, and we are serving both a mobile app, customer pages, admin pages, and an Apex application with the same business logic. And we have one API set of packages for, we're using ORDs for REST services with GraphQL on top of that one again, so that we have one set of external API packages for ORDs, and we have one for the Apex stuff, so that we know where is this being used from. So they're just basically thin wrappers. And we also create views though, so that the nice capabilities of Apex can work. Resources, just for reference. I don't think we have time for questions, but we might run a little bit over. And I know from experience that there are basically no questions here. Nobody? Everything clear?
Yes.
Okay. Oh, I have one question for you. So are you the guys with the crappy code who needs tools like this, like me? Okay, you're laughing because I did this presentation at Open World and people are like, yeah. and I did it in Germany, and I was like, oh, so you're the guys with the crappy code, and they were like, no. Well, thank you for coming. Great having you here. If I can come back next year and talk about Logger, I'd be happy to do that because it's a great tool. Okay.
How to install that tool?